This is the unit review for Physical Science 8th grade, Unit 2, Chapters 1 and 2 regarding matter. All right, first up is some review vocabulary words that you should already know, but I wanted you to remember them, so I'm going to reiterate them. So the first one is molecule. Okay, so remember a molecule is when two or more atoms bond together. So they combine, creating that molecule. This can be made up of different types of atoms, different types of elements, or it can be all of the same element. One example of it is an H2O, being two hydrogens and an oxygen formed in a bond. That is a molecule. Molecule is also sometimes known as the smallest amount of a substance, but it's still considered to be that substance. You can break a glass of water all the way down into individual molecules of water, but if you break it any further, you're going to break it into hydrogen and oxygen, and then it's no longer going to be a molecule. Molecules in air are constantly moving, and that's why when you look around a room, as you're viewing a room, you're going to see little particles of dust and lint and things like that. Those are moving around, and that's because the air molecules, or the molecules of different elements in our atmosphere, such as nitrogen, oxygen, those sorts of things, they're constantly moving. Atoms are always in motion. Remember that. Atoms are always moving. Always moving. Important distinction there. Always moving. They're never still. And one way that you see that again is that air, as particles in the air are moving around, you're going to see those little bits of dust and so forth move around as well. Now, everything in our world is made up of matter, right? Now, it can be pure or it can be a mixed substance. Remember, a pure substance is just that. It's pure. It is all the same element. So it's all of one type of element. An example of this is something like a gold bar. It's all AU. So it's all that element AU in a gold bar. So something is pure. Is a bottle of water pure? Well, no, because typically it has other things within it. But if it were pure water, then it would have only H's and O's, all in an H2O format. However, pure silver, it contains pure silver. Now, most coins and jewelry, they're not pure. They have little bits of things in it, just like the water we drink has other things in it, like iron and fluoride, and those other elements that are actually good minerals that we need in our bodies. But it's not a pure water. You need to know the difference between an element being all of the pure items. These are a substance only containing a single type of atom. Single type of atom. Now, the next one is a compound. And a compound is going to be a substance that is made up of two or more different types of atoms that are bonded together, right? They have to have that bond, so it's two or more atom. Let's put different types of atoms. And so they make a large variety of substances because they are combining different items, different compounds, such as water, carbon dioxide. So they're bonded together. Table salt, that's another example of it. Our last one is mixtures. Right? Now, most of the matter around you is made up of a mixture. Our air that we breathe is different types of elements in it. Remember, it has oxygen, nitrogen, carbon, different elements within it. Seawater contains water, but it also has salt in it. along with many other minerals also. Your blood has blood cells and plasma, right? And plasma is made up of other things too. So these are all different mixtures of different elements. Okay, a couple different differences between compounds and mixtures. So a mixture remains the same substances. They do not combine. Compounds form new substances. Mixtures can be separated by physical means, such as the lab we did the other day with dirt, salt, and pepper. Compounds can only be separated by separating the bonds between the atoms. And you're going to find that the proportion of different substances in a mixture can vary throughout it. It's not going to be the same. However, in a compound, they are the same. So it's going to be the same throughout the entire compound. Last point on mixtures. So the thing about a mixture, the thing that makes it obviously a mixture, is you can see the different substances in it. Say you look at a handful of soil. You're going to see the different components within that handful of soil, and so that tells you that it is a mixture. All right, so next up is solids, liquids, and gases. Now, these are all states of matter, and I want you to take a look at a picture. Okay, so this is a picture with the 3 different states of matter. So we have solid, liquid, and gas. Now, you'll notice in the solid, this one over here, that the particles are close together, right? And they're fixed in place. They're going to vibrate, though. So that desk that you have, that computer, the computer I'm working on right now, the tablet, all of that is solid, but the atoms inside it are still vibrating. They're still moving. They just can't go anywhere. They're packed in there so tightly, they can't move. Now, liquids, right? They are close together, but they're farther apart than they are in a solid. They can kind of slip and slide freely past each other. And then in a gas, they're really far apart. They're going to spread apart. They don't like to be near each other, so they're going to spread apart and move however they want. Okay, so back to these solids. These all have a definite volume and a definite shape. And I'll talk about volume here in just a minute because I'd like to talk about how we measure that, but that's actually going to be a little bit later. All right, so then liquids, they have a volume, but they do not have a shape. They're going to conform to the size and the shape of whatever container they're in. Gases have neither volume or shape. So they don't have a volume or a shape. Their volume changes to match the volume of the container. If I have a balloon, right, the gas is going to spread inside the balloon. Molecules in gas, again, are very far apart. You'll see all this extra space that's around them. So there's lots of space between the molecules in there compared to a solid or a liquid. Right, now we're going to talk some more about matter. So matter, which is the entire reason for this entire unit that we're doing. So matter, again, it makes up all objects and living organisms in the universe. Matter is everywhere, on everything. It's everything is made up of matter. However, matter is anything. Here's a definition for you, right? It equals anything that has a mass and takes up space. Okay. Remember, mass, right? Oftentimes we think of things in the matter of how much they weigh, but that's not what we do in science. Mass is the measure of how much matter an object is made of. Okay, how much matter that an object has. Again, I know that measuring mass and measuring weight can be a confusing thing to know. So again, remember that mass, right? is comparing the mass of the object with a standard amount or unit of mass. Now, if you measure weight, you're going to use a scale, and it's going to tell you how hard that object is pushing or pulling on it. You're going to be comparing how much basically gravity is pulling on it. Okay, so I said earlier that I wanted to talk about volume, so let's go back to volume, right? Now the volume equals the amount of space that matter in an object occupies. In order to find volume, you're going to use a specific formula. Volume equals length times width times height. For example, if we have a pizza box, see my bad drawing here. Okay, pizza. And it is 38 by 38, and its height is 8 centimeters, then what you're going to take is you're going to take 38 times 38 times 8, and you're going to get 11,552. Never forget to put on your label. Your label in this case would be centimeters cubed, because we've taken it and we've taken the cubed measurement. We've taken 3 measurements cubed, so we're going to have that 3 there. Okay, physical and chemical properties of matter. So if we look at this physical properties, okay, physical properties, these are the things that can be observed, right, without changing the identity of the substances. So let's talk about a couple of these changes in physical properties, right? I can stretch a rubber band. And is that changing the physical or the properties of it? It's or the identity of the substances? No, it's still the same identity of that substance. It's still a rubber band. I'm just changing its physical properties. Mass and volume are 2 physical properties, right? Measuring these properties, it doesn't change the substance. They're still going to be the same. All right, another physical property is density. We did this in the lab with the syrup and the water and the oil, and then we made the big, huge density tower. So density, remember, is, first off, it's expressed in a grams or per cubic unit, so centimeters cubed. And density is the property of matter. It represents the mass per unit volume. So if we look at this, we're going to take density equals the mass in grams divided by the volume in cubic centimeters. So this is going to be cubic centimeters, and this is going to be grams. Let's do a quick example of this. If I take this formula and I substitute some information in there, such as 13 grams over 5 centimeters cubed, this is going to come out to 2.6 grams per centimeter cubed. And this is actually the density of glass. All right, so we've talked about physical properties, but now let's talk a little bit about what a physical change is. Now, let's go back to physical property again. That's when it can be observed without changing the identity of the substance. Now, the physical change is the change in the physical property of a substance. Again, it's not in the substance itself. The substance is going to stay the same. We're just changing the way it looks, basically. We're breaking a piece of clay in half. that stretching rubber band, that's changing its physical property or its physical observation, but it's not changing the actual substance. Water changes from ice to gas. Well, that's again not changing the physical property, it's just changing its state of matter, basically. Now, a chemical change is different from a physical change. Again, the physical change does not change the substance. However, a chemical change does. It describes how a substances form new substances. Okay, some ways that you can see this is the ability to burn. That is the biggest one. If it is able to burn, then you know that that is a chemical change. You've created a different type of substance. Other possibilities include combustibility, the ability to rust, the ability to tarnish. So taking into consideration those things that I talked about, a piece of wood burning, chemical change. Iron fence rusting, that's a chemical change. A silver spoon or a silver necklace or a silver piece of jewelry, it tarnishes, that's a chemical change. An egg cooking, when you take a raw egg and you make it into a hard-boiled egg, it's a chemical change. Remember, the true way to tell whether a chemical change has happened or a physical change is that in a chemical change, a new substance has been formed. In a physical change, you do not get a new substance. You're just changing the properties of how it is observed. All right, final section. The final section has to do with the properties of substances. And so one of those is, how do we identify different substances? How do we use those to separate mixtures and that sort of thing? So let's look at some of the things that we look at to identify them. So the first one is density, which we already talked about. The heating properties. Okay, so if we're talking about heating properties, that's where they respond to heat in different ways, right? You can measure how fast does something heat up or cool down. So those are the heating properties. The electric properties. Does it conduct electricity? Does it conduct it better than other things? We know that certain metals conduct electricity very, very well. Plastics, they don't. Then, let's see, the next one we're going to talk about are its magnetic properties. If I'm looking, or if I have a substance, I'm going to look at, does it respond to a magnet? If you've ever pushed a magnet around in earth, you'll notice, or in dirt, you'll notice that some of the particles in there will respond to the magnet while others won't. Well, that's because of their physical properties inside it. And our last one is solubility. We did this the other day when we used water to separate the salt from the sand and the pepper, right? It was able to become a solution by combining the salt and the water, which caused us to be able to tell what kind of substance it would be, or it would allow us to do that. All right, that marks the end of the chapter review for this unit, and study hard.